Hello. By now we have learned rational inequations, introduction. Then we know method of intervals. We know some standard rational inequations also. But we haven't done yet many problems. So let us have in this session more illustrations so that you get grip on the topic. So this session would be only for more examples. I start with first one, and that is we have to find number of integer values of x satisfying 2x minus 1 upon x minus 5 less than 1. And some 4 options are given. Now before I start formal solution, I'm just giving you one small tip that in this session, whatever method or whatever style of solving we adopt, that you please pay attention to every small looking step even, because this topic is comparatively new to you, and from examinations point of view that this topic will become somewhere some small step. So what happens that if you do not have grip on the topic, then somewhere unnecessarily you get stuck. So it's better that you practice a lot, and practice means there are not any thousands of problems. Very small tips are there. If you stick to those basic steps, I'm sure you will not go wrong. So let us start with the problem that it is 2x minus 1 upon x minus 5 less than 1. Now this question is not in the form with which we actually started, that rx less than 0. So my first advice to you would be that we bring it to rx less than 0 form. And how do we do it? That by perhaps taking 1 on the other side. Why do I do so? That x minus 5, I'm sure most of you would think that we should multiply on 2 sides. But sign of x minus 5 is not known to us. It could be negative, it could be positive. If you wish, you can multiply, but then you will have to maintain that if it is negative, then by multiplying, that sign change will have to be brought in. So instead of increasing number of steps, better is that you take 1 on the left hand side. So we avoid multiplying by x minus 5. And if I take it on other side, that 1, if I take on the left, I realize that I will have to take LCM and usual simplification, school method, like whatever you have done. And I simplify and I get it as x plus 4 upon x minus 5 less than 0. Now I'm sure, now this inequation is equivalent inequation of the given inequation. So whatever are the solutions of given inequation, they are going to be solutions of this and vice versa. So we know now, since x plus 4 upon x minus 5 is less than 0, its solution, where does it lie? That x plus 4's critical point would be minus 4, x minus 5's critical point would be 5, and then since it is strict inequation, so they will not participate in the solution set, and then actually if you wish, you can mark on the number line and check where does the solution lie. Solution would be between minus 4 and 5. Why do I say so? You know method of intervals. You can check actually by taking any point from any interval, substitute in the expression x plus 4 upon x minus 5 and check whether that sign is retained or not. That same method you can apply, and I arrived at minus 4 less than x less than 5. And question says the number of integers we have to find that satisfy the equation. So minus 4 is not to be included. So it starts from minus 3. So minus 3, minus 2, minus 1, 0, 1, 2, 3. And then 4. So in all we have 8 integers. So number of integers is 8. So my correct answer is B. I hope one tip you understood from this particular question. Otherwise question didn't have any special treatment, except that what 1 was occurring on the right hand side, we added minus 1 on 2 sides and we brought the inequation to the form Rx less than 0. Then let us move to next. Now next inequation looks lengthy. Treatment would be almost similar to what we did before. That my aim would be that I replace it by Rx less than 0. So I look for some equivalent inequation. So what I do, I take that 1 upon 2 minus x on the left hand side by actually adding minus 1 upon 2 minus x. So that on the right hand side I get 0. Then take LCM, simplify, usual your 7th, 8th standard algebra. And then on simplification, at the end, I arrive at 2x minus 1 upon x into x plus 1 into x minus 2 greater than 0. If you look at those last 2 steps, you will realize that I had minus 4x plus 2, and in the next step I have 2x minus 1. That means minus 2 I have removed from the numerator. And in the denominator, there was a factor 2 minus x in the previous step. And in the next step, I have written it as x minus 2. So 1 minus 1 I have removed from there also. So numerator's negative sign and denominator's negative sign will nullify each other. So I have not brought any sign change, and the last expression what I get is 2x minus 1 upon x into x plus 1 into x minus 2 greater than 0. Now this is typically in the form of Rx greater than 0. I will have to find numerator's critical point, denominator's critical point. What would be numerator's critical point? Nothing but x equal to half, one expression only. And in the denominator I have x, x plus 1 and x minus 2. So critical points are 0, minus 1 and 2. I mark it on the number line. By marking, what has happened? That minus infinity to minus 1, one subinterval. Then minus 1 to 0 I have. Then 0 to half I have. Half to 2 and then 2 to infinity. So I have lots of subintervals. Now what method is preferred? Method of intervals. Pick up any interval and any point from that interval. Substitute in the expression and check whether sign is retained or not. Then I get that minus infinity to minus 1 will satisfy. Then I get 0 to half, that will satisfy, and then 2 to infinity will satisfy. So my solution set is minus infinity to minus 1, union 0 to half, union 2 to infinity. And that seems to be the D option. So you have arrived at the solution set. This question again was another exercise for bringing inequation to the form either Rx less than 0 or Rx greater than 0. The corresponding or required changes, whatever are to be brought in, with all patience you have to do. It's simple algebra. I move to next. And next inequation is that how many integers do satisfy the given inequation. The given inequation is 3 times absolute value of x minus 1 plus x square minus 7 greater than 0. Now, actually if you look at that inequation, it looks as if that absolute value inequation has come here. But actually that is not the case. This inequation, since I am taking it in rational inequations, so it is expected that somewhere we will be using method of intervals. Another thing what I observe about this inequation is that right now it is not in the form of px upon qx. So if at all I have to use method of intervals, qx perhaps I must be taking as 1. So let us start. I write inequation first, then I will be taking perhaps cases x less than 1 and x greater than 1. So my first case is x less than 1. So absolute value of x minus 1 will be replaced by minus of x minus 1. And inequation will be written as, in the simplified form, x square minus 3x minus 4 greater than 0. Factorize it normally. X minus 4, x plus 1 greater than 0. If you wish, you can take it as x minus a, x minus b greater than 0 form, find critical point, or go by method of intervals, and then I find the solution set as x less than minus 1, or it would be 4 to infinity, that is x greater than 4. Critical points, don't forget that they are minus 1 and 4. Now, as I said, it is not in the form standard px upon qx. Qx will be taking as 1, and it is nothing but a strict inequation. So, critical points will not be in the solution set. Don't forget that. Also, if I am going to take x greater than 4, then this will not satisfy the condition x less than 1. So, x greater than 4 is rejected, and then we take combined case of x less than minus 1 and x less than 1. So, obviously, x less than minus 1 would be taken, and I realize that x less than minus 1 is a solution. Now, this is only one case. Now, again, second case you will have to take separately, x greater or equal to 1. And then again, absolute value of x minus 1, use definition, replace it by x minus 1, and simplify further, you get x square plus 3x minus 10 greater than 0. You know how to factorize it. That is x plus 5, x minus 2 greater than 0. As I said before, again I repeat, either you use method of intervals or go by x minus a, x minus b greater than 0. Critical points would be minus 5 and 2, right? And then I find the solution. How do I find? Using method of intervals. X less than minus 5 or x greater than 2. Now again, we are in the region x greater or equal to 1. So obviously x less than minus 5 is of no use. So x greater than 2 and x greater or equal to 1, these are to be combined. When I say combined, we have to find the common region. And the common region would be nothing but x greater than 2. So I realize that x greater than 2 is a solution. Now I combine 2 and 3 because either case 1 comes or case 2 comes. I'm saying or. The moment I say or, you must take union. So my solution set from here would be minus infinity to minus 1, union 2 to infinity. But our aim is not to find solution set. Our aim is to find how many integers do not satisfy. Mind you, please, whenever you go for any competitive type of examination, read question carefully. Question says how many integers do not satisfy. And if I look at the solution set, minus 1, I have written with round brackets. So minus 1 is not included. Similarly, 2, I have written with round brackets. So 2 is not included. So the required integers would be minus 1, 0, 1, 2, which are not there in the solution set. So which all values do not satisfy? That is minus 1, 0, 1 and 2. So how many integers do not satisfy? 4. So the correct answer is A. So please realize this, that objective type of questions also need some working. Please do not jump to the conclusions without working. Do basic simplification and arrive at the answer. That's all for this session. When we meet next time, we may be taking more examples. Thank you.